what this says, in a polynomial, which is what we were talking about yesterday, if f of a, oh goodness, and f of b have opposite signs, there is a 0 between a and b. Here's what that means. Let's say I have a and b. Okay, those are just two x values. If they have f of a and f of b have opposite signs, that means the y at each of them. So one of them has to be a positive and one has to be a negative. So let's say this one's positive and this one's negative. If we're talking about a polynomial, I told you yesterday that the graph of a polynomial is always a nice smooth curve. No breaks in the graph, no corners. So if I'm going to connect those 2 points, the only way to get from a positive to a negative is by crossing 0, isn't it? So it's saying if you know that this graph switches from a positive to a negative or vice versa, then the only way to do that is by putting 0 in between. So in the next few weeks, we'll start talking about, finding the zeros of this graph. And it's going to help us to know that if I plug in a 1 and get 5, and then I plug in 2 and get negative 6, then there was some number between 1 and 2 that would have made it equal 0. That's all this is telling us. Alright, so let's look at how I might ask you to use this right now. So here's my polynomial, x cubed minus 2x squared minus x plus 1. And I want to show it has a 0 between 2 and 3. I'm not even asking you to find out what it is. I'm just asking you to prove to me that something between 2 and 3 would make this equal 0. What we need to do is find the y values for each of this. So if x is 2, how do I find my y? Plug it in for x. That's all we have to do there. So I'm going to find p of 2. Use your calculator if you need to. I get 8 minus 8. So that equals negative 1. Alright, now what should I do? Plug in 3. I get 7. I'm sure you guys are checking me, right? Okay. All this says, these are like points on the graph. When you have 2, you get -1. When we put in 3, we got out 7. Since it's a polynomial, I know it's just a curve connecting those, so what has to happen between 2 and 3? Has to cross the x-axis. So on these problems, there's really 3 things you have to do. You have to plug in the first x value, you plug in the second, and then you need to tell me what happened. So I'm just going to write a very simple explanation here. The sign changed. So there is a 0 between 2 and 3. For some x value between 2 and 3, this thing would equal 0. Let's graph this on our graphing calculators and see if we can agree with that. So use your Chromebook if you don't have a calculator here. So you need to go to your y equals and type in your function, x cubed minus 2x squared minus x plus 1 Okay, so if you're looking at your graph, here's 2 and here's 3. Does it cross the x-axis between those? If I asked you to approximate that, do you guys know how to use the trace button on your calculator? If you just hit trace, you can move your cursor around and kind of get an idea of where that is. At the bottom it tells you your x's. So it looks like it happens at about 2.2, 2.3 if I'm using my trace. That's when it's on the x-axis. Does anybody need me to help you see that on your calculator? Show you where the trace is or how to use it? Any questions on that? So here's a question for you then. If you plug in 2 values and you get the same sign, does it mean there is not a 0 between them? Yes? We have a yes and we have a no. So like if I put in -1, and let's say I got 1, and then let's say I put in a 2 and got out a 4. Both of those are positive. Does that mean it can't cross 0 between them? No. It may mean that. I mean, I may have a graph that looks like this and doesn't hit 0. Or I could have a graph that looks like that. So if they're different signs, it tells us that there is definitely a 0. If they're the same sign, it really tells us nothing. If I'm asking you to use the intermediate value theorem on a problem, most likely it's probably going to change sign. But if it doesn't, then you just say, we don't know. It doesn't really help me out. Okay, any questions there? the last thing I want to talk about today is synthetic division. Do you guys remember doing that? You have done it. We'll see if you remember or not. If I asked you to divide, let's say, I asked you to do this. We can do long division, but that really wasn't anybody's favorite, was it? I mean, I don't think anybody was jumping up and down every time we did long division. So, synthetic division works as long as what you're dividing by is linear, just to the first power. Remember, we would make a box out here, and for that box you have to look at what makes this 0. So what would make x minus 3 equal 0? 3. So you put a 3 in the box. And then we're just putting coefficients. We leave off all the x's. So this was a 1x to the third, so you put a 1. 3x squared, so you put a 3. I do not have an x. So what do we have to put? 0. A 0. It's very important with synthetic, if you're missing a power, you put a 0 for its place. And my constant is -4. Is this looking familiar at all?
Yes.
So the first step, your first number comes all the way down. So I just bring down my 1. And then it's a series of multiply and add. So you multiply the number down here times the number in the box. So 1 times 3 is 3. So we put it. And then we add. 3 plus 3, 6. Multiply. 6 times 3, 18. Add. 0 plus 18 is 18. Multiply. 18 times 3, 54. Add. -4 plus 54 is 50. Have I lost anybody there? Last step is just to write our answer. This number is your remainder. This is your constant. This would be an x squared. Your power specs just go up. So we have a 1x squared, or just x squared, plus a 6x, plus an 18, plus for your remainder you do 50 over what we were originally dividing by, x minus 3. And that's our final answer. So far so good? Let's do another one. So the first step is to figure out what goes in the box. You have to think about what makes what you're dividing by equal 0. So what would make an x plus 2 equals 0, and that's -2. So a -2 goes in this box. Then we put our coefficients. So we have 5x cubed, -6x squared, -28x, and a +8. I don't need any zeros because I had every power of x. Then what do we do? Yep, for first number comes all the way down, and then we multiply and add. So 5 times negative 2, we get 10. Add, multiply negative 16 times negative 2 is positive 32. Add, we get 4. 4 times negative 2 is negative 8. Add, and we get 0. So this is my remainder, my constant x and x squared. My answer is 5x squared minus 16x plus 4. Since my remainder is 0, I don't have to put that. So that's our final answer. What I will be asking is to decide if things are factors or not. And basically, if it's a factor, that means it divides evenly. If it divides evenly, what's your remainder? 0. So if we divide it and just get 0, we could say it's a factor. It goes in evenly. Sometimes, if all we care about is the remainder, you actually don't even have to do the full division. If x minus, let's just say k, is a factor, that means f of k equals 0. What I mean by that, look back at this previous one. Grab your calculator. We did our synthetic with negative 2. What I want you to do is plug a negative 2 in for your x on this. So go back, put a negative 2 in for all of the x's. Make sure you put the negative 2 in parentheses with the exponent on the outside. What do you get? 0. When we plugged in our negative 2, we got 0, which was the remainder. On our problem before, we put 3 in the box. So I want you to take 3 and put it into the original equation here. So 3 to the third plus 3 times 3 squared minus 4. What do you get? 50. 50 was our remainder. So if you plug in this number, you're just going to get the remainder every time. And if it's a factor, that means the remainder has to be 0 because it divides evenly. Alright, any questions for me? I am stopping here today. So here is the plan for the week. There is a Math Excel assignment open. It's got a lot of questions from 4.1 within behavior, so some really quick ones. And then there's some synthetic division. Tomorrow I'm going to finish section 4.2, and I will open up a second Math Excel. So this is today, this is Thursday. Friday, we are going to have a work day in class. So go ahead and start this first one. I'm giving you 13, 14 minutes right now, so you can get a lot done. Tomorrow I'll finish the sectioning, open up a second Math Excel. Both of these are due after our workday Friday. Okay, so I have it currently set at the end of the day on Friday. If I need to make it until Monday, I can. But we're going to have an entire class period on Friday to work in class and ask questions if you need to. Yes. Oh, yeah.
It's only 3 minutes left.
Thank you. I was thinking I just had all kinds of time today. Forgot to go.